Hello everyone, this is Ehsan. In this video, we are going to speed up the root finding process, square root finding process using a idea called binary search. So if you want to find the square root, so before I even talk about that, what is binary search? So if you want to find the value square root of 5, we know that the value lies between 0 and 5. What binary search says that since the value is between these two values, what we can do is we can take the mid value as the initial guess. So the mid value is 2.50, and we compute the square of that guess, and which is 6.25. And if we compute the error, so 6.25 minus 5, we see that the error is greater than 0. So using this value, we are actually overestimating the value of the square root. So it's an overestimation, so it's greater than 0. So there is no point in searching any numbers in between this range, because any number that we guess here will have a value greater than 6.25, so it will always overestimate and the error will be always greater than 0. So what it does, it essentially removes all this section from search and only computes within the range 0 and 2.50 in the next iteration. And the way we update the guess is again by taking the midpoint of these two numbers, which is 1.25, and then if we use this as the guess and take the square, we get 1.56. And if we compute the error, which is 1.56 minus 5, we get it's negative 3.44, which is less than 0, so it's an underestimation. So any value here will be a lower value compared to this, so the value will be always underestimating. So we understand then that the approximate square root is somewhere in between, and that's how we take for the next iteration. We take 5 to search. So in the next iteration, when we want to search, we search within this range. So that's how binary search works, and we are going to implement this function using a while loop. So in order to compute the square root using a binary search, what we do is we copy all this code, because most of the code will be similar. We paste it and we say that computing square root using binary search. So we have all these things again, number of guesses, and everything is fine. So what we do is basically say that our initial value is 0, which is the min value that we are going to start looking from, and this is the final value inclusive. So we say that let's say double min lower limit is equal to 0.0, while the upper limit is equal to the value. And then what we do is we go and do the while loop. We say while true, it's always true, and what we do is we make our guess, which is double guess is equal to lower limit plus upper limit, bracket close, bracket open, divided by 2.0. And then what we do is we make the error computation, we get the absolute value, and if the absolute value is less than or equal to the closeness factor that we have selected, we say that we have found the guess, so we return the guess. Now let's look at the two else conditions. First is the else if, where we check if the error is greater than 0, we do something, and else, which is the default thing, if none of these things works, we say that which means that it's less than 0. In that case, we have to update our lower limit to, so if this is the case, we update our lower limit to guess, else we update the upper limit to guess. And let's check. So the idea is, if the absolute error is very close to what we have selected as the closeness factor, we say that we found the solution, and we return the guess, and we also print how many guesses we needed to find the solution. If the error is greater than 0, so if this is the case, so if the error is greater than 0, what we do is we update the upper limit, which was 5, to 2.5. So that's what we do. We update the upper limit to the guess, which was the midpoint here, and if it was less than 0, in that case we update the lower limit to guess. So that's what we do. So we update the lower limit as 1.25, and that's how it works. That's how we reduce the space of search by half at each iteration. Now if we run this code, let's see if it's running. Control R. We give 5 as the input, and so we are using the previous function. So it says that the result is 22,339 iterations. After 22,339 iteration, we find our closed result, which is this. And if we include our binary search algorithm, what we see is we can do it here like this. We can say that, okay, copy this thing, paste it here, we copy this, and so square root of value using binary search. Using binary search is, let's see, I made a mistake. I should not use double again, so let's run it again, because double was initially initialized here. Result was initially initialized here, so if we reinitialize it, it gives an error. So we do 5 and we enter, and we see that in one case it took 22,000, and with the binary search it gave a better result. However, it only took 8 steps. Now there are some certain conditions that we need to understand here. Conditions meaning that there are a few subtle things that we need to improve in both these cases, both the search routines, the linear search and the binary search. Say for instance, what happens if the value is between 0 and 1, or because if it's if the value that we want to, whose square root we want to compute, is between 0 and 1, in that case it always gives a higher result than the value, so our algorithm will fail. For example, let's try this. We want to give the value 0.5, and you see it doesn't return any result because there is no result from 0 to 0.5, because the answer to the square root of 0.5 is somewhere in 0.71 range, so it's beyond this value. So the linear search and the binary search both fails. So we need to somehow change this code. We'll see it in the next video.